Good morning students. Here is our next video, that is solubility of gases in liquids. Solubility we already discussed in previous video. And see, the solubility of gas is measured in terms of mole fraction or in molarity. So here we start the factors affecting the solubility. The first factor is nature of the gas and solvent. The most soluble gases are those which chemically react with the liquid solvent. Clear? For example, ammonia. See, ammonia is highly soluble in water because it reacts with water and forms NH4OH. Similarly, SO2 with water forms H2SO4. HCl is also highly soluble in water because HCl is a polar molecule and water is a polar solvent, so like dissolves like. Whereas nitrogen, oxygen, hydrogen, helium, all these are less soluble in water because all these are the non-polar molecules and water is again polar solvent. So here the solubility of non-polar molecule is less in a polar solvent. Okay. The next important factor is temperature. See, temperature is inversely proportional to the solubility of gas. Clear? Solubility decreases with increase in temperature. Why? Because the solubility of a gas in any solvent is an exothermic reaction. And according to Le Chatelier principle, any exothermic reaction is favorable at low temperature. Okay? So, simply the solubility decreases with increase in temperature, especially the solubility of gases. Here we have important board question, that is, aquatic animals like fish feel more comfortable in lakes in winter than in the summer. Why? The answer can be explained in terms of two factors. One is temperature and another one is pressure, that is the Henry's law. So here we discuss only temperature. So on the basis of this factor, we can easily explain the answer. How? See, the aquatic species require dissolved oxygen for breathing. Correct? So if the solubility of gas decreases with increase in temperature, so obviously the less oxygen will be available in summer. Because in summer the temperature is more. As the temperature increases, the solubility of oxygen decreases. Clear? And so temperature is important factor. Our next factor is pressure. Pressure is directly proportional to the solubility. Solubility increases with increase in pressure. And it also follows the Le Chatelier's principle. This effect of pressure is explained by the Henry. So, and he gave a Henry's law. So, to understand this, we consider a gas which is in dynamic equilibrium with the solution. Here see, it is a gas cylinder. It is fitted with a piston, which is a frictionless piston. Now, this is here at the bottom, solution is present, means solvent plus gas, and this vacant space is occupied by the gas molecule. It is in equilibrium. Equilibrium means now if one molecule of any gas will enter at the same time, one molecule will leave the solution. Clear? If we increase the pressure, see here we have P1 plus P2, means we increases the pressure. So the number of molecules in the solution is more. Means maximum molecules of the gas dissolved in the solution. So simply the solubility increases with increase in pressure. This solubility can be expressed in terms of mole fraction or in terms of molarity. Here we will take mole fraction. So simply the partial pressure of a gas is directly proportional to the mole fraction of gas. Means partial pressure means the pressure of the pure gas, which is directly proportional to the mole fraction. Clear? So according to Henry's law, the mass of gas dissolved per unit volume of the solvent at a constant temperature is directly proportional to the pressure of the gas in equilibrium with the solution. See, P is directly proportional to X. If we remove this proportionality constant, then we have to add another constant, that is KH. Here P is equal to KH into X, and this KH is known as Henry's constant. See, Henry explained this by taking an example of HCl, and here he draw a graph between HCl and the mole fraction of, means the partial pressure of HCl, which is taken in torr, and its mole fraction. And after plotting this graph, we get one straight line. Straight line means what? It shows that pressure is directly proportional to its mole fraction. Clear? So simply, according to Henry's law, the partial pressure of gas is directly proportional to its mole fraction. Now this KH is Henry's constant, but KH is different for different gases at constant temperature. Means the value of KH is at different temperature will be different. Why? Because partial pressure of different gas is different. Clear? So KH depends upon the nature of the gas. Clear? Means its solubility. See, P is equal to KH into X. So KH means what? We can write P by X. If P is the partial pressure, means if this is the constant, so KH is equal to 1 upon X. Means KH is inversely proportional to the mole fraction. And mole fraction means what? Solubility of any gas. So simply, if the Henry's constant is more, so its solubility will be less. Clear? The next one is, see, KH increases with increase in temperature. How? Because as the temperature increases, the mole fraction, that is solubility, decreases, and mole fraction and KH is inversely proportional. So KH increases with increase in temperature. This is Henry's law. In next video, we will discuss about the advantages of Henry's law and its disadvantages. Okay?